Good afternoon, everyone. I'm here to talk to you today about how the Institute for Minerals and Energy Resources at the University of Adelaide is developing some novel systems to lower the cost of energy for mining, mineral processing and energy applications. We all know the importance of mining mineral resources for the raw materials that sustain our quality of life. We all know the importance of these industries for the Australian economy. They are credited with saving Australia from some of the worst effects of the GFC, and in the South Australian context, the export value of those industries is the largest portion, accounting for more than agriculture, food and wine together. But there's many challenges confronting this industry, in particular the cost of energy. We've heard from many speakers today already the importance of looking to low carbon solutions, but even apart from that, for mining, mineral processing at the moment, energy is a significant cost, typically between 25 to 35% of their input, sometimes up to 50%. So even while there's a lot of talk about carbon tax and the increase that will make on a whole range of industries across the board, there's enough drivers out there in any case for these industries to look at alternative options to decreasing their cost base. But even apart from that, as Graham sort of mentioned before, the growing developing countries such as India, China are wanting energy resources to sustain their economies, to grow their economies. So there's more people out there globally competing for energy, and that's probably going to be the main driver pushing up energy costs. So therefore that's going to have a risk and a potential impact on these industries and the Australian economy. Hence, mining, mineral processing, energy resource companies are seeking low-cost ways of supplying energy for their applications. And one of the main ways then that they're looking at that is renewable energy. That offers the potential to be not free energy, but energy from the wind, sun or geothermal offers a pathway to low cost. But there's a number of barriers at the moment for that are preventing that from being deployed around in the industries. So one of those barriers at the moment is, apart from the geothermal example, which does offer the potential for baseload power, is the intermittent nature of those sources, such as solar and wind. We don't control when the wind blows or when the sun shines. That's a risk for mining mineral industries which want to run 24 hours a day on a reliable basis. Another key barrier at the moment is cost. While off-grid sites such as diesel do have higher capital costs or running costs with diesel, the range of energy sources, particularly solar thermal, are more expensive than that. So that's a key barrier. But probably combined with that, the intermittency cost, its risk as well. You know, the operations in mining, mineral processing need to be assured that they can run, they can deliver. The key driver at the moment for these industries is to get product out the gate, not necessarily to decrease their costs, it's to get their product out to market. So how can you make renewable energy lower cost, reliable and guaranteed when you need it? That's one of the opportunities that the Institute for Minerals and Energy Resources and the Centre for Energy Technology, being part of that, is addressing through some novel ways. And the novel way that we're looking at doing that is not by being purist about it, by being it's 100% solar here, it's 100% wind, it's 100% geothermal. The reality is that 90% of the world depends on fossil fuels at the moment. That's where these systems are, that's where the experience is. How do we bring them together in a hybrid or integrated approach? So there's a range of different technologies and systems that we are working on at present and are seeking to develop that are looking at that novel integration approach. So one of the ways that's up here, or part of it is on the screen, is around electricity production. In a thermodynamic cycle, you have a boiler, you have a system that provides a heating to that. And there are power plants out there at the moment which we would call conventional hybrids, where you can have the energy source from a combustion power plant and a solar thermal plant, and they all feed into the turbine in the middle. And that way you get a bit of the solar, or it can be geothermal boosting, coming into that power station. What if we combine that boiler into all into one? What if we have one vessel that has fuel burning it and a solar coming into that? That's a project that's been working on at the moment and is also the subject of a bid to the Australian Solar Institute next week, in which and that offers the potential in that combined receiver to decrease the capital costs. We don't have a separate solar field and a separate combustion plant, we've got them all in one. So that can potentially reduce the cost by 50% of an integrated power station. But that's just for electricity production, and that's one of the other ways that we are seeking to look at renewable energy is not just for electricity production. To get away from thinking it's wind, solar, you've got to end up with electrons. At the end of the day, the bigger picture is we have an energy source. We have the sun, it's radiation. We have geothermal, that's, when it's extracted, it is hot water. Can we use that energy, instead of converting it, putting it through a conversion process, which decreases the amount of energy you actually can use at the end, can we use that directly? Can we look at some other ways of capturing that energy and then getting away from the intermittent sense then, and just by putting that into a process? So some of the ways that we can look at using that is in geothermal, is by saying, well, we've got a hot water source there. That's essentially what we get out of the water. But rather than needing a high flow rate, high temperature geothermal source that we might need to then turn that into electricity, well, what if we can use a moderate, less high temperature, less flow rate, and use that water somewhere in a mining and mineral processing application? So let's maybe put that hot water through a leaching process that will help accelerate that process. Is that a way of getting the geothermal industry started or up and going, and finding another way of decreasing the cost base for mining and mineral processing it the same way? Can we use solar thermal energy in a different way? Can we concentrate it to a certain level so it's slightly hotter than it is on a normal hot day, but can we put that to a certain extent and put it again through a leaching process to push along a chemical reaction as part of the leaching process, so we don't need to use much acid in the application? Or can we concentrate that radiation even further to get a higher temperature, but instead of using that to drive a electricity production reaction, can we use that to create a thermal shock, which might fracture a particle? So instead of having to do a whole lot of crushing through a mill, or we probably still need to do that to some extent, but you've taken some of that load off by putting that through a solar process. And again, you can do that when the sun is there, when it is not, removing some of the intermittency nature, but also leveraging off the existing infrastructure that's out there already, so you're not putting as much risk out there, you're still using the existing processes. Or is there another way that we can do it by converting some existing fuels? So in South Australia, we have a lot of low-grade coal, brown coal feedstocks that are pretty uneconomic to extract, but offer potential energy sources. So rather than using some other energy, fossil fuels, to extract them, can we use the sun to gasify some of that coal, convert it into a syngas, which we can then use directly in a process, or you could even convert that then in another process to a liquid fuel? Can you looking at using that same process, gasifying a carbon fuel stock in another way from the sun? So can you use waste tyres as an example as well? In the mining industry, lots of waste tyres. That contain a lot of carbon. Can you still get the embodied energy in that waste material and turn it potentially into a fuel stock? And biomass is the same way in that case as well. So these are all concepts at the moment. In general, they're not. Some of them are projects to some extent, but I guess today in presenting these ideas, these are not. We are seeking involvement, and we're working on some of these projects through IMER to seek partners and take them forward. So happy to discuss that later with anyone. The reason why we are looking at the hybrid sort of option, integrated option, particularly at the University of Adelaide, is the core capability, particularly in the Centre for Energy Technology, is around thermal engineering, understanding, in one sense, combustion applications and radiation. So combustion is just one form of energy release and one form of radiation. Solar or geothermal is just another form of radiation. So it doesn't really matter whether it comes from a flame or it comes from the sun. The underpinning science of understanding how to use that energy for a particular process is the same. So we're looking to translate that underpinning expertise and the facilities that we have which is some of the best layers of diagnostics laboratories in Australia for investigating reacting flows and combustion, to put that together with the solar reactions or the geothermal processes. We've also got the second largest wind tunnel in Australia as well that can be used for energy-related research. So we're looking to use that, apply that again for any of these projects. And we also have the South Australian Coal Research Laboratory, which is set up for gasification experiments as well. So we think the combination of resources, expertise and facilities is, as well as the natural resources that South Australia has in terms of solar, geothermal and wind, is a perfect environment to get these hybrid projects up and going for the benefit of industry here, being mining, mineral processing, but also to develop the know-how and IP around how to develop the hybrid solutions and translate that out into other markets. We think this is all is viable, can be done, because the Centre for Energy Technology has a long history of turning those results with industry into outcomes. There's 7 patents that the CT has around combustion applications. That's probably what Rick could churn out in a weekend, but we think it's not too bad as far as the university goes. And we're also very experienced to working with industry. I think over the last 5 years, it's 200 collaborations and various range of projects, from consulting to longer 3-term ARC linkage style projects, with a range of track records of turning that into being awarded through government awards and outcomes from industry. So I hope that's given you an overview into hybrids and where we think the potential is, and very happy to discuss where we can take that further if you're interested. Thank you.